and
Okay.
all the states, especially the
Okay.
8 Northeast states. We have representation from the 8 Northeast states.
How do you communicate at the beginning?
No, before we formed this society, we known to each other
Okay.
through some program or through our works, and we were friends also.
Okay.
So yeah, our Dr. Pautown took the initiative with Monali, me, and Dr. Temsu. We all come together and we implement our ideas, and we come up with first activities and one talk series of
Okay.
Tibeto-Burman. So we were just we have a series of talk starting from November 2020
Okay.
till today. This, as Monali pointed out, this will be the last talk of our weekly talk. So in the previous talks, we have lectures or the presentation from different linguistics area, field of study, and some of the members were asking us also that if we can have some talks from NLP area. And we have very few people, so just came into my mind that Tamo is a very known figure in NLP who is working, who is working in many projects also as well. So we just thought that why don't we try to invite him? Then you accepted in, like that we come up in this way.
Yeah.
I'm just trying my best because, like, at the beginning when I started working for NLP, I was thinking the same. I mean, I was in the same mood. Like for the rest of the language, they've already started working in NLP, but for Manipuri, only few people were working. That's the reason why I pick up NLP. Otherwise, I would have moved to some other specialized area also. Because of the love of the language, I just come up with NLP. That's the reason. And now we are all in the same line now. So maybe it will be very interesting.
I have just put it live.
Okay, then Monali.
I didn't want to come in between because you were giving introduction about Tiblane and both of you were in a conversation.
So, okay, yeah, please go ahead, Monali. Yeah, now you can go ahead.
Okay, let's start, right?
Okay.
Okay. Good evening to all the participants present here in the 17th and the last Tibeto-Burman weekly talk series of Tiblane that started from November. And with us today, we have our speaker, Dr. Kishorjit Nongmeikapam, and he's an assistant professor of IIIT Manipur. Before he begins his talk on understanding the techniques of computational analysis on natural language, let me give a brief background of his profile. Dr. Kishorjit has done his PhD in Jadavpur University in 2016 on the studies on the role of MWE in NLP. He has done several projects during his research, and for his current research, which is auto-navigating auto-navigating e-card using multispectral imaging, he has 3 PhD scholars and computer technician working under him for
Monali, we are not able to hear you.
I think she has
your internet problem maybe.
This project, which has started from 2009.
Okay, Monali, we were not able to hear you for a couple of minutes. So can you repeat once again the last one?
Okay. Dr. Kishorjit has published a textbook, See the C, letter C, in 2014, which is about the C programming language. He has 47 research papers to his credit. He has been invited for several talks and presented several papers in international seminars and conferences. He has also organized workshops and conferences in IIIT Manipur and MIT Manipur University as well in recent years. He's also an editorial board member for Several journals such as International Journal on Soft Computing, Artificial Intelligence and Applications, International Journal of Computational Linguistics and NLP, International Journal of Emerging Technology and Advanced Engineering. He has also been an editorial board for conference proceedings of um, regional publications from IIIT Manipur and MIT Manipur University. And he's also a founder president of NLP organization, which is NLPAM. And also he is a member of ACL-SIG and MALADS. Without further delay, I'd like to request our speaker, Dr. Kishorjit Nongmeikapam, to kindly deliver his talk on understanding the techniques of computational analysis on natural language. Thank you.
Thank you, Monali. Thank you, Monali, and thank you, Vijen, for inviting me to present what I have in my mind, to share my knowledge among few scholars, or otherwise to the people who really want to understand the relation between computer and the natural language. Thank you once again to your organization, a group which is created for Tibeto-Burman language. So most probably my lecture today will be helpful, and I am trying my level best to just make it as basic as possible so that everyone can understand. Suppose if I have gone a little bit more technical, maybe it may not be at the level of what a linguist can understand, because there are a little bit of difference between computational concepts or otherwise engineering concepts and linguistic, but still we are trying to bridge it up. And the area which is very much, what to say, popular nowadays. It's the bridging between the computer and the natural language. So that's what I will try to bridge up a little bit today, so that the future generation or those people who haven't come across all these things can understand what people can do and what the future, what we can develop in future. That's the thing I just want to share today. So my topic today will be the understanding the techniques of computational analysis on natural language. This is what my topic goes. And most probably I'll try to just come up with the concept of the natural language processing, and maybe those types of artificial intelligence or machine learning. So these two will be hybrid here, and then maybe everyone can understand how these things are really working. So let's start with it. So my presentation will be like this. I'll try to talk about bridging the gap between the computer and natural language. Then I'll try to just introduce a little bit of AI or machine learning, then all the relationship in NLP, and then we'll move on to the techniques of computational analysis on natural language, which is nothing but a hybrid of the NLP and what we talk about, what we call as artificial intelligence or machine learning. Okay, so let's see what we have. What I have in my presentation. So let's see here. What happened here is we'll try to bridge what computer can do and the natural language. So like what in the real, what at present what we people are trying is we're trying to replicate the behavior of human by the computer in every aspect. That is what we are trying. So what happened is, like, the computer engineers or computer scientists, they know how to code the program, or otherwise they try to communicate with the computer through programming codes, or this may be a means of communication with the engineer and the computer, or otherwise you can call it as a machine. So that is one part. Then another thing is, in another part, say for example the human, we try to communicate among ourselves through our natural language, like maybe your Hindi, maybe your Manipuri, maybe your Nagamese. All these things are the natural language which comes naturally for the human. So now, as I pointed out in the first point, that the computer is trying to replicate what human wants, or otherwise maybe a humanoid is the ultimate goal for we human, because we are so lazy that we just want to make the robot come to assist us. So we cannot keep programming. We cannot keep doing the programming stuff for the robot. What ultimately what we require is, we require to communicate straight away to our natural language to the robot. That is the ultimate goal of the human race. So what we can do is, why not we design, or why not we come up with certain certain algorithms, so that we can just talk in our normal language, and the human and the robot can understand what we just want to instruct, or what we just try to convince the machine or the system or the computer. So that is the thing, how this thing is coming up, and we human are trying to breach this gap. So not everyone is a wizard, I should say, because maybe my specialization is programming, and your specialization is language. So it's not like that you will be able to program, or maybe even though I'm expert in programming, I may not know that much in depth about the language. So what we can do is, we can just come up, or otherwise collaborate linguist, the concept of a linguist and the concept of a computer engineer, so that we can just mend the gap between these uh, two entity, that is computer and the natural language. So at the beginning, people start talking about computational linguistic, but to my concept, the computational linguistic is little bit what to say, a little bit away from what we call as natural language processing at the present stage. Computational linguistic at those days were something where the computer tried to assist the linguist to teach or to learn the language. But now, with the concept of natural language processing, what we are trying to do is, we are trying to set up certain system uh, through the program, as what the general people understood about the natural language. So it comes the concept of natural language processing. So by natural language processing, what we can understand is, it will be a blend, or it will be a hybrid of what you call as the what to say, artificial intelligence, or otherwise the machine learning, and then that will be blended with what we a linguist know, or otherwise the rules of, or the grammar of the language. We'll be trying to mix it up, and then the product will be nothing else but the natural language processing. So that is the beginning of the concept of this natural language processing. So now, if you look at this picture, what you can find is, uh, if you look at in this picture, if you look at this, it can be drawn with three axes, in sense. One is what you call as the language. Okay, so this tree is very important. The first one is your language, which will be in this axis. The second one is the problem in sense, like what we want, because like with the language, there will be certain rules, there will be the grammars will be there, and then we'll be targeting certain objectives. That objective is nothing but a problem. So now you have a language, you have all the objectives, what is being targeted, and then the computer engineers will try to design some algorithm in sense, will try to set up some program, so that we can solve this problem. So that is the target of NLP. So you have, this is a three axis sort of thing. if you draw it in graph. So again, the another part of NLP in basic is that we can target the work of NLP through text, or otherwise through speech, I mean through sound, or otherwise maybe some sort of images also. Because like, as you might have heard about OCR and all, optical character recognition, where the characters are being recognized through certain software. So once we can recognize the characters in the document, we can just straight away apply all these algorithms so that we can meet the objective. That is the beginning of what we understand about natural language processing. So a little bit of deviation from what computational linguistics talks about. Now, if before going all those details, or otherwise, I would like to just what to say, brief about the techniques and all, because that is my topic. So before going all those things, I'll try to just introduce what this artificial intelligence is, or otherwise what this machine learning is. Once you know about this, it will be very, what to say, conceptually, it will be very easy for you, like how it is really working in natural language processing. So that is my objective here in this lecture. So maybe we have already I mean, we have already come across AI. We have already seen in movies and all. We have already heard about, I mean, we have already heard people talking about artificial intelligence and all. As the term itself, it is artificial. Intelligence is what we people know it, like how, I mean, intelligent, by intelligent, we have to have the capacity to decide in any circumstances and any instant of time. We'll have the capacity, we should have the capacity to decide what is good, what is bad, or what should we do, or something. So what happened here, I mean, in this slide, I'm trying to just give you some hint about the AI and machine learning. So computer, maybe what we may be thinking, like computer is so smart. To be very frank with you, computer is so silly. The computer doesn't know anything. It's only we human who made this computer very smart, very smart. And how this is being, how this is possible? Because the computer engineers or computer scientists tries to give some instruction behind the scene, so that how this computer can react, or how this computer can just come up when some what to say, sudden what to say, reaction is required. That is what the AI is all about. It's not like the computer knows everything. Computer doesn't know anything. It's the instruction given by us that makes this computer intelligent. So what happened is, we suppose like computer, how this computer start learning, that we can just talk about. If we give an instruction to them, like whenever someone asks you what is your name, and if I write a program, say like whenever someone this term comes up, because even A, B, and C, whatever character we are using in the computer keyboard, this computer doesn't know at the beginning, or otherwise only the software is just reacting with what we have typed on from the keyboard. So starting from that, we have to keep on what to say, upgrading the things, so that computer will become intelligent. To the definition of AI, we can just say that it's an optimal search. Optimal search in sense, like when some work is assigned, or some what to say, work is assigned, what happened is the computer is searching for some answer among the list of answers, so that the maximum benefit, or the optimal answer, or the best answer is being presented to the what to say, to the one who just want to get the answer. So optimal search is what this AI is all about. We'll have a list of things of that. the computer, the algorithm which we have inserted will try to search the best answer among all those answers which is being listed. That is what the AI used to do. Say, for example, someone is playing chess. So in the chessboard, you have all this rooks and knights and everything, queen, everything. So say, for example, each coin on the chessboard has has a chance to move in different positions. The way we have designed an algorithm in such a manner that the coins which is on the chessboard has to move in the best attacking way, or otherwise best way to win the match. That is the thing which we write in the algorithm. So the computer start reacting whenever the opponent move the coin on the of the chessboard. So what happened here is the computer is trying to find the optimal search among all possible moves, so that so that the computer can win the opponent. So what happened here is, the concept here is, the human has programmed something so that we give a lot of options to choose. Among that the best option is being chosen by the computer. So that is how the computer reacts, and then the users start thinking that the computer is so intelligent. In reality, computer is not so intelligent. Okay, that is the concept. That is the starting concept. So now how this computer is learning is, like, we have to, the computer at the beginning, when we talk about artificial intelligence, computer start learning through the instruction or how this programming is to give. But of late, there is some deviation from the classical AI. In the classical AI, that is what I have explained now, just before what I have, just few minutes back. But now the thing, or the train, has changed. Now the thing is, the computer start learning itself. How? By the technique called machine learning. So this is it's an advanced form of AI. We can say, like, it's an advanced form of AI. So at the beginning, it was an optimal search. Now the computer start learning itself. There are two types of learning. Yes, of course, this happened to human also. How this is happening to human? First, we call it as supervised learning. This happened at the early stage, like when we are child. We used to learn it from the teacher or from the parents. Say, for example, if I have to learn ABCD or 1 to 3, which is the basic of a language, what we do is we keep learning, because our teacher or our parents used to teach, like, this symbol is A, this symbol is B, this symbol is C. So what happened here is, we know the output. And based on the input, we come to the conclusion that this step should be this step should be this. At the end, what we have learned is, it's a supervised learning. Supervised learning, in sense, it is, the output is known, like, this will be A, this will be B, this will be C, which is being already there, and we are trying to mark it up again and again. Then we started learning in that process. That is what we call it as supervised learning. What about the unsupervised learning? Later on, after learning all those things, we just come up to a level where we started learning through experience. We started observing the things, and then we learn ourselves. So that is what we call it as unsupervised learning. Even the computers are also following the same rule, and then the computer is learning in these two processes. One is supervised learning, another one is unsupervised learning. So by unsupervised learning, the computer is learning. The output is not known, but it's learning through experience. So this two type of learning is, very popular nowadays. Apart from this, we have another learning method called deep learning, that also I'll try to explain in later part. But so we before going with all the NLP works, we need to know little bit, or we need to have this little concepts of supervised learning and unsupervised learning. One is like we have to learn it through ourselves. Another one is through, I mean the outputs is known, or otherwise we will be supervised. Then only we'll be learning. So that two method is being implemented in the computing world. So you may be asking like how it is going to happen in how it is going to happen in the learning of the natural language. Yes, of course, we'll be applying that also. Before that, I'll just show you like as I have started talking about the intelligence of a computer. So I'll just cite a simple example how this what to say intelligence is all about in the computer. So we have supervised learning, we have unsupervised learning. Then apart from that, I'll just cite you one example like how this real intelligence is all about. Say for example, we have some groups here. We call it as, and I'm citing you an example of KNN. We call it as some classifier. I'll just explain you how the term intelligent comes up for the computer. So like say for example, there are a few groups when I join some institute. When someone join an institute, few people will have different groups coming together, laughing together, discussing together. Now what happened is uh, we try to, because which means like there are some k number of groups. Okay, what I'm going to do is, this is me, a new fellow in the institute. Okay, I'm trying to check it out. Or the computer is trying to check it out. Among these 5 fellow here, 1, 2, 3, 4, 5, this fellow is trying to check it. Among these 5, who will be the best friend to him? Say thing like this is the computer. As soon as he reach an institute, this fellow is trying to find his fellow mates or some best friends among these 5 students. Okay, so he need to be intelligent now. Unless he is intelligent, it won't be possible for him to choose the best of the best among all those people, so that he can accompany in the rest of the year. Okay, so now how it is happening is, so like let's use a very simple mathematical concept. We know about the Euclidean distance. Okay, we'll try to find it out. A simple thing. Okay, say for example, if we have to go with all the intelligence sort of thing, this happened even to the human also. We try to check it out, the characteristics of every one, so that we can identify whom can be my friend. In that similar concept, what the computer will start choosing, or will start finding is, what is the age, what is the income, what is the credit card number, or something. So like I'm trying to find out the closeness of it. Okay, so there is a formula here. I missed that formula here. Anyway, I'll just solve it out. So like say for example, the characteristics of John is 35. This fellow John is having an income of 95,000. He holds some 3 credit card. Rachel is of age 41. Income tax, income is around some 215,000. Credit cards, he's having some 2 credit card. So what happened is, we try to find out the distance between John and Rachel, because the formula is like square root of these two. All these differences. Okay, that is what the Euclidean distance says. Okay, so I'm trying to find out the distance between John and Rachel. Distance in sense like, the similarity between these two fellow. Okay, with some some example. Let's come back to straight away to this chart, so that you'll be able to understand, because I have listed some 5 fellow David is no one else but the computer. He is trying to find out like who are the best guy to him. So what happened is he is trying to use the formula of Euclidean distance and start finding all the, by getting all the data of all the things which we are, which each and everyone is having. So David is trying to find out. David is trying to find out the distance among all these things. So what happened is David can find out. David can just find out that there are people who are really, really common on among themselves. Say, for example, look at this, and look at this. These three can be in a what to say, in a level where they can group together. Whereas Hannah and Tom, they're of higher class. So what David can understand is, David can find is, even David has to find the Euclidean distance with among other things. So what happened is, these three can be grouped together based on the Euclidean distance. So David says yes with these three people. David, which is nothing but the computer, will start saying like he can just accompany John, Rachel, and Nelly. Apart from, he won't be interested to Tom, he won't be interested to Hannah, because their class is different from what David's class is. So the computer will start choosing, like will be start choosing in a very intelligent way, that he will start introducing to John, he will start introducing to Rachel, he will start introducing to Nelly. He won't be introduced to Hannah and Tom, because their class is different from the David's class. So that is the concept, how this intelligence work. So at the end, when this David starts selecting John, Rachel, and Nelly, everyone will start saying like, yes, David is so intelligent. But in reality, this all comes up through some algorithm. So to me, as a computer science, computer engineer or computer scientist, we won't say like David is intelligent. But to a NAPE user, the user will be saying, or the one who is observing David will be saying like, David is so intelligent because he choose those fellows who are very intelligent. So that is the starting point of what we call as the artificial intelligence or something. So this is how the concept of intelligence works in the computer. It's not a straight away sort of thing for the computer to become intelligent. These small algorithms are tied or are being programmed in the computer so that the computer becomes, or otherwise the robot becomes intelligent. Now coming back to the point which I just started which I have started discussing, like the topic of NLP. So we have a brief idea about the AI, and then I have given a little brief about machine learning, and now we'll just come back to the natural language processing again. Say, for example, we have to work on the natural language processing. So what happened here is, as I already mentioned in the first slide, maybe in the second slide, about natural language processing, we can work on speech or text, because the language is being expressive or is being expressed through speech or otherwise sound or through text. This is the two basic thing. But yes, of course, nowadays we can consider talking about the image also, because we are very fond with OCR also, optical character recognition. If someone is having an image where all these documentations are there, say for example the all manuscripts won't be in digital form, it will be something in the image form. If suppose if you archive it, you will be archiving digitally through some scanner or something like that. Those things, with the help of OCR, you can just convert that particular image to the editable text. Once you get that editable text, the process is the same. Similarly, for the speech also, if you have a speech that is nothing but the noise, I mean the sound only. So once you have the sound, and if you can come up or otherwise convert it into text, then it will become the normal procedure, or otherwise the vice versa. It's not like every time we have to come up from, I mean, convert speech to text, or maybe from something from image to text. It's not compulsory that every time we have to convert it to text. It can be the vice versa also, but the simplest thing is converting to text, because we have already started working various things on text. That's the reason people try to just convert things, say for example from speech to text, or otherwise from image to text. That is the concept, but in reality it can be anywhere. It can start from anywhere. So so the input, if we have to work on natural language processing, then the input can be speech and text, or otherwise an image. Then what happen is we will work on a subtopic called the natural language understanding. Okay, so you have the concept, or a layer called natural language understanding, NLU. In the NLU, what happened is we'll try to find all this basic concept or basic requirement of the language, say maybe the lexical analysis, the syntactical analysis, semantic analysis, discourse integration, or pragmatic analysis. Say in the lexical analysis, I mean, we'll try to uh, try to find the token in a sentence or something, because what happened is, once, if you want to process the language, we have to, or otherwise when you have a sentence of a particular language, you have to find out the token of each, I mean token in each sentence, token, or otherwise the words. You have to find out all the words. Then another thing is, maybe like you have to find the syntax of the sentence. As we all know, like each and every language, what to say, the rule is not that similar. Say for example, the syntax of English will be something like subject, verb, and then will be followed by an object. Whereas some language like Manipuri, Hindi, all these things, like all these languages, what happened is the structure, the syntax will be subject, object, and verb. So what happened is there is some difference between what to say, subject, verb, and object, or otherwise subject, object, verb. So these are the syntax, a simple concept. So we need to identify how the syntax is. So we need to design a system. We need to design, or we need to come up with an algorithm to check the syntax of the sentence. That is one area where we can work on basically. So starting at the lexical level, we'll be looking into the tokens, we'll be looking into the spelling, all these things, like even a spelling checker, or otherwise a spell checker becomes wordful for those who really work on natural language processing. Because unless you check the spelling, when you come to the semantic level, it is not going to give you the correct answer. So lexical analysis is important. So you can start with all this lexical analysis, where you can come with all this spell checker and all. Then next comes to the sentence level. You can go to the syntactical analysis, or you can design an algorithm where you can just check the grammar of the sentence. So that's where the basic rules will be coming from the linguist, and the computer scientist will be designing the algorithm. Then comes the semantic analysis again. Semantic analysis, where the meanings are to be checked. You may need again a very large lexicon, because unless you find a lexicon, you cannot just come up with the semantic ideas. So that is another area where we can work on for the natural language processing. So basically the backbone lies with the linguist again. So all these things, what happen is, whatever we are going to learn, or whatever the computer engineers or the computer scientists will be designing, the backbone will be the linguist, because the computer engineer or the computer scientists are doing something which is on top of what a linguist has already done, because the backbone or the real rules will be given by the linguist. So that is one where, I mean, that is the area where we can start. And then once you get all those things, we'll start generation. Generation in sense, it will start giving you a system which can find what is required, or otherwise the objectives. As I have already shown in the previous slide also, like we will be having a problem here, or otherwise objective here. This is the objective, and that objective will be identified, and that will be, I mean, that objectives will be here. So the generation will start. I mean, the generation of what our objective will be started. So things like even here, say for example, morphological generation. This is another important thing for, especially for the Tibeto-Burman language, because I mean, this is more important, especially for this Manipuri also, because Manipuri is a very, I mean, is highly agglutinative, as everyone knows it. Even a single word can mean almost a sentence if we, what to say, translate it into English. So morphology, identifying the morphology is again an important issue, or otherwise another important thing that will come starting from the lexical analysis. Once you get, you have an lexical analyzer. In that lexical analyzer, you need a morphological analyzer again, where each and every morpheme will need to be identified. Unless you identify it, we won't be in a position to find the root word, because when the language is rich with suffixes and prefixes, what happens is the root word will be, what to say, the meaning of the root word will keep changing with each and every morpheme you will be, I mean, attesting to that particular root word. So that is another important area where we need to think about. Maybe the linguist may be thinking like, if we design, if we give some rules, certain rules, that will be enough for a computer scientist to work on it. But to be very frank with you, it is not an easy task for the computer engineers to find the solution, or to give you a software which is 100% accurate, especially for some language. Giving you or otherwise a software which can just identify the morphemes. So what happens is, sometimes not all the rule work. We need certain things sometimes in order to identify, or in order to generate what our target is. So rule based sometimes fails somewhere. So sometimes we need what we have discussed earlier, like machine learning sort of thing. We need to infuse some sort of AI in order to generate, or in order to make it more accurate, apart from the rule base. Of course, say for example, for the English, we have a very good algorithm, which is almost a rule base. The algorithm is the Porter stemmer, where the Porter identifies certain rules which can just give you an accurate root of the word. I mean, stemming can be done. Stemming in sense like all the suffixes or prefixes will be removed in order to get the root word. So that is how every linguist has to work on, and has to come up with certain rules which can give an accurate, what to say, root, which can stem the word into 100% perfection sort of thing. So that is where a linguist can work. The linguist can come up with the rules, and then the computer scientist can just generate some algorithm which can just give you the accurate one. So that is one thing. Now, what happened is, at the beginning, people start talking about NLP everywhere. Now the thing is, I mean, it's little bit changed, or otherwise the paradigm as of now is little bit changed, because we started thinking out of what we start, I mean, what we know about NLP. At the beginning, only at the beginning, we only know about NLP, and we started thinking like NLP will be the only thing which will cover everything. Yes, of course, it covers everything, but I mean, nowadays, people started dividing the NLP again, like the NLU. So, what happened is like in the NLP, what happened is the basic things will be created first. The basic things like NER will be created first, like name entity recognition. Why this is required is because there are certain chances of having ambiguity. By ambiguity, I mean, like, say for example, let's get in sentence. Let's get an example sentence, or otherwise we can talk about what the word Washington. If I say Washington is in America, Washington is in America, it is very ambiguous now. We may be thinking like this: Washington is a person, or the other, or my friend will be thinking like Washington is a place name. So there is a confusion when you try to translate it or to some other language, from English to some other language. There may be a confusion here, like whether this Washington is a person or this Washington is a name of the place. So there may be some confusion in that. Or otherwise, in Manipuri, if I say like Sauba, for example, the word Chauba. Okay, Chauba means big. So like if I Sauba can be a name also in Manipuri. So like there is a confusion when someone tries to translate from Manipuri to other language. I mean, someone tries to, in sense like the computer, let's get an example of the computer. When computer tries to translate those sentences, there may be a confusion to the computer, like whether this Chauba is supposed to be translated in the semantic way, or otherwise the system has to consider it as a name. That's the place where this name entity recognition is necessary. So that is one part. Or then I mean, the mother of, or the mother rule for a grammar is nothing else but the part of speech. When I try to, or whoever want to learn the grammar of that language, the first thing they need to know is the part of speech. The same thing happened for the computer also. When we try, or when the system, or when the computer when we try to implement the NLP, or otherwise when we start designing the algorithm, the first and foremost thing which is required is the part of speech, because each and every word has to define or take with the part of speech. Unless we know the part of speech, it will be very difficult for us to work on with the next level. So part of speech taking is also another important thing. Then all these things, like maybe like text categorization, syntactic parsing, and then co-reference resolution, machine translation. Machine translation is one, I mean, another area where people want to work on. For the other languages, they are so advanced. Say, for example, the Google Translator. In the Google Translator, when you try to type something, and say a sentence, for example, maybe in English, like, how are you? The Google Translator had an option in which language we want to translate. That can be choose from the list of those languages, and then the Google Translator will automatically translate the sentence which you have typed or as an input. So like by machine translation, we mean translating from one language to another language. So it's not an easy work, especially for the Tibeto-Burman language. Maybe for the human, if we want to translate things, it will be easy, but for the machine, it's not an easy task to come up to the level of machine translation. And to add more salt for the machine translation, in the Tibeto-Burman language is the agglutinativeness. Being highly agglutinative, it makes more complex, translating from one language to another. Say, for example, let me cite an example of example from the thesis of Nongmeikapam. There is a word called Pusin Hanzaranga Davanidako. Yes, everyone who is an expert, who is expert in Manipuri or who knows Manipuri will understand this word. If we have to translate this particular word, Pusin Hanzaranga Davanidako is a single word, but when we try to translate this into English, this particular word will almost come up to a sentence. Like, I wish I would have asked him to do it. So this is the meaning of that particular word. So in that circumstance, how are we going to make the translation? How this machine is going to translate from one particular language to another language? This is another complex part or a complex issue. So that those are the things. So now, these are already started. At the beginning itself, I already mentioned about this. Like, we need to get it in terms of sound as an input, or otherwise text as an input. Okay, or otherwise the vice versa. So things is like we are changing from text to speech, or maybe from speech we can just again change the thing. Now this is the concept, or this is the beginning, or otherwise this is the present paradigm of NLP. Now you have in the inner part, you have the NLU. NLU is nothing but the application of all the NLP work. Application in sense like maybe semantic as a sentiment analysis, dialogue agent, paraphrasing, maybe proofreading, maybe summarization, and semantic parsing, all these things. Why? Because these are all important, because like, if you know the language, you need to apply it somewhere. Because let's look as an example to human. When we understand the language of someone, we can understand the attitude, we can understand the expression of the other fellow. That is what is happening here also. Say, for example, sentiment analysis. So by sentiment analysis, what happened here is we are trying to analyze the sentiment of a person, or otherwise the sentiment of his or her expression. The sentiment, the polarity of the sentiment can be positive, negative, or neutral. Because the expression or the word, the feedback will be maybe the positive or negative or maybe neutral. Say, suppose if I come up with a sentence like, I want to kill you. If suppose this is a sentence, the sentiment of this sentence is nothing but a negative one in normal. Why? Because I want to kill you in sense like someone starts saying all these things when he or she becomes angry, which becomes, it's not a neutral one, neither it is positive. It becomes a very sensitive one, expressing the angerness. So that's where this thing can also be understood. Or someone maybe like some critics used to give blog or something like that. Maybe article or something like that, or maybe the review of some movies or something like that. As soon as it comes up on the, or as soon as a movie is being released, the next instant, all the movie critics will start giving the abstract of that movie. From there, we can understand like the movie is good or bad, or maybe a neutral one. So how to find it out? With the expression or with the word which is being written over there as an article or as a review, we can understand that this movie is going to be is already a hit, or it's not. It's very. It's dull one, or otherwise it's a normal one. So that's where it is required. That's where the sentiment analysis is required. And one more thing, if I tell you very frankly, the robots only know zero or one, or otherwise it's very rigid. Yes, no. So what happened is, robot doesn't even know what love is. Because they don't have sentiment. The computer doesn't have any sentiment. Did you find any computer started following you? No. Did you find any robot started saying you I love you whenever you put on the computer? No. We haven't ever find any of the system admiring us. So the thing is like we're lagging on this part. If we want to replicate things, if we are really talking about the replication of a machine of human by a machine, then this sentiment is another area which is very much required, because we need to infuse the sentiment of something sentiment to the robot, so that the sentiment of the robots can say like, say like he started loving the the person who is very near to him or her. Because we are going to advise the robot, because robot are being designed in such a manner that they assist the human. So if suppose they are supposed to assist us, it cannot be rigid every time. It cannot be a 0-1 sort of thing every time. Robot should also understand. Robot should also have sentiment. Because when I assign something to a robot, the robot, and if I left the place giving some assignment to him, the robot should also think about plus point and negative points. So that is where all these things is required. Even in the forensic science, it is required about the sentiment. Because if suppose someone is found dead somewhere, just before the moment that very particular person was texting someone else, if suppose the text which is just sent before his death can again be used in the forensic science, like the text may be in a very good form, or otherwise in the positive form, or maybe in the negative form. Say for example, if someone texts to someone else like, I just want to die today, which means like, it will be a suicidal case. Otherwise, where just moment before his death, if suppose he or she texts to someone like, I love you, or something like that, which is very, in a very positive mood, it cannot be a suicidal sort of thing. It will be almost a murder sort of thing. That also can be analyzed from the sentiment, or sentiment of the word or expression which he or she has given. So that is where we can implement. Then you go to question answering also. Question answering, what happened is, this will be another future. This will be another future in sense like, we teacher, for example, at present, because of the corona pandemic, what happened is all the study or all the learning teaching process becomes online. What about the exam? Exam is another hurdle for us, for the teachers. How to give the question paper, and how to download the answers, and how to check it. Yes, of course, MCQ is a very simple thing. What about the short answer type question, and what about the long answer type questions? Will it be possible for the system to just give the grade or give the mark automatically? That may be another question now. Yes, of course, we can start working on that also. With question answering, if it is almost 100% perfect, then one day there won't be any university, physical university, or any colleges or any school. There won't be any existence of any of the school, colleges or university. All will become virtual, because even it won't require a teacher also for checking the question answer, or otherwise teaching will also, teacher will not be required even for the teaching. Why? Because the question will be set by the system, the answer will be checked by the system, the marking will be done by the system, everything will be done by the system. Even, at the end of the day, what will happen is, a single person will start owning one university. And it will become very cheap also. Cheap in sense like, you don't need to pay in terms of lakh in order to study in that particular university. Because it will be very simple now. It won't involve any teacher also. University will become virtual. Colleges will become virtual. Institute will all become virtual. So that is one part of, one advantage of question answering. So this is somewhere I have already seen, I have observed, or I have come across some system which is almost up to the perfection for question answering. Another example, simple example, is your Google or the search engine, where you type the question and the system or the search engine used to give the related answers. That is another simple example, because in the Google, in the text box, you will be typing what you want. You'll be typing like, where am I, or whatever it be, where it will answer automatically. So that is where the implementation of this question answering is coming. Then also you have summarization. Summarization in sense like, you don't feel of reading the whole newspaper, which consists of around some 10 to 20 pages. You want to summarize, you just want to come up with the breaking news only. You try reading only the headings only. When you are interested, you move inside, you go read down there, finding out what is, more interesting. When you have found something which is more interesting, then you start reading all those things. So summarization is another area which is very much required. So those are the things: summarize the whole event or summarize the whole document and get it done, and then you will be analyzing. After analyzing the summarized part, you'll be going in depth with what you are interested. So summarization is another interesting area for the NLP work. So these are other things. So if I keep on discussing about all these things, it will take a lot of time. So let me wind it up. But these are some of the few important things or few interesting examples which I can share with you. Now, coming to the main part, in sense where we have to follow the computational, the techniques for computational analysis on natural language. We, at the beginning, maybe the linguist may be thinking like, all the language, if we have rule, it can be, an algorithm can be designed and it is solved. The thing is solved. Maybe what the objective is, or what we want, or what is required is solved through the rule which the linguist has designed. But in reality, in some of the cases, not all the rules are applicable in computer programming, because in some cases it becomes more complex. So these are the things which we have to keep in our mind when we are really working on natural language processing. So basically, whatever it be, we can start with the rule base. Then from there, we can move little bit on the statistical method, or otherwise the probability method. Statistical in sense like, we need to collect a lot of things, lot of data, the corpus itself, and then we need to find out the probability of, the probability of, which gives the highest probability. We have to find the condition which gives the highest probability, and we will be concluding there. Okay, that is what statistical method says, and then we'll have some advanced method also. Fine, we'll check it out how these are all working. Say, for example, the rule-based tagging. It's nothing but a linguistically motivated rules, or usually rule built manually. So a linguist will be designing certain rules, and with that rules, the program will be, the algorithm will be designed, and then it will be, the objectives will be met from the rules which is being infused. Or otherwise, it's a knowledge-driven tagger. If it is a POS tagger, then it is a knowledge-driven tagger. Then let's say, for example, let's get into the example here. We know when it is secretariat, or otherwise when things are started with capital letter or something, it is a noun. Then those like is and all are be verbs. So like that, with the rules which we are having, which the linguists used to give, the system, the computer engineer can design a very simple algorithm so that it can generate the objective. So this is one of the example. If this is the sentence with the rules, we'll come up with all the tagging here. Like secretariat is noun, proper noun, be verb, or then verb, all these things. So this is rule base. The rule base where it's a linguistically motivated one, or the rule are being given by the linguist. Now, look at here again, another one. I can create, or I can come to the root word called pu. As I told you, like this is an example in Manipuri, like Pusin Hanzaramga Davnidako. Okay, which means like I wish I would have asked him or her to do it. That's the meaning of this word. A very long sentence. The complexity here. But here, if I have to go to the root word, or otherwise if I have to design a stemmer, it's so simple applying the rules. How? I'll be trying to remove all the suffixes. I'll be having a list of suffix. I'll be having a list of suffix here, maybe 72, 73, something like that. I'll be finding out whether that particular substring is there in this suffix or not, and I'll keep on removing one after another. If I find any of the suffix in the list, if I remove it continuously until I find all those substring in this string, I'll be able to find the last root word. So that is another simple method. Pu is the root word. Pu is to take. Like even in the lexicon or otherwise in the dictionary, we used to find out the root word first. After that, the extended words are. I mean, we try to find the extended words. Searching in an algorithm in a dictionary, we try to find the root words only. So that is the concept, and same thing happened for the system also. Same thing happened for the computer also. The computer tried to generate the root word first in order to go at the level of semantic. So that is another thing. Maybe this is really working well for some of the words, some of the Manipuri word, but sometimes it fail in other word too. Say for example, impal. E is a prefix. So if I say like E is a prefix, and if I remove E from impal, that won't work again. So what happened here is we find the idea of overstemming, and I mean, we sometimes find something which is being overstemmed. Overstem in sense like we remove more than what is required, or otherwise sometimes understem. Understem in sense like we are not in a position to remove all those suffixes in order to reach the root word. So understem sometimes happen, or overstem sometimes happen. So rule base sometimes don't work accurately in some of the word. So we can say like rule base are not always perfect. In that scenario, we require the concept of machine learning sometimes. Machine learning in sense like or otherwise the statistical one sometimes. The frequently occurring sort of things, the frequently occurring bunch of substring. If I can identify all those frequently happening sort of thing, then it may be concluded that that particular frequently having substring is a root word. That is also a possibility. Forget about the rule. Let's forget about the rule, but we can even come up with the frequently occurring thing that, please wait, my power is down. Okay, fine. So frequently occurring things can sometimes be considered for some of the cases by neglecting the rules. So that is what is going to happen with the probability, or otherwise statistical method, or otherwise the machine learning method. That I'll be discussing with you maybe in the next slide also. Like say statistical method, we'll try to find out the most probable one among a large observation. We'll have a large observation. Of that observation, we'll try to find out the highest probable or the highest probability, and we'll try to consider that probable one as the best one, and we'll be concluding that that is okay or that is right. That is what this statistical method says. Again, I can just say the reverse one. All the statistical results which is being given by the system may not be always 100% right. There's another one. So rule-based may not be 100% right every time. Again, this statistical method may not be again 100% right. So maybe sometimes we may need a hybrid sort of thing also. So for let's check out like what all these things are. I mean, how all this thing can be done in natural language processing. As we all know, if you people have the background of the probability, you might have come across the chain rule and all. Yes, of course, the formula is here. I'm not going to discuss much on the formula, but let's see straight away, or otherwise, let's go straight away to the example here. If suppose there is a sentence or otherwise a phrase like the man from Jupiter, to us, to human who understand English, he or she can straight away say like this phrase is right. There's nothing wrong in this phrase. But to the system, to the computer, we need to just instruct some algorithm to verify that whether this phrase is right or wrong. Say, for example, look at this phrase, the man from Jupiter. We'll be trying to find with this formula. Okay, we'll try to find the probability of the, okay, here it's the probability of the main, which means like probability of main given the. We used to read in this manner in the probability, or otherwise it's something like the probability of the main. We are trying to find the probability of the main in this case. Again, this is another probability we are trying to find. We're trying to find the probability of the main from. The main from. Again, here we are trying to find the main from Jupiter. It's a chain rule. It's a probability of chain rule. We are trying to find out the probability, the value of the probability here. As we all know, like the probability will lie from, this probability will lie from 0 to 1. This x, the probability of x should always lie from between 0 to 1. When it is 1, it is perfect. When it's 0, it's not going to happen. So it should lie from 0 to 1. You may be thinking like how we are going to find the probability of such thing. That's where the term corpus come. For the English, we have corpus for BBC, Reuters, all those newspaper agencies. They used to publish newspaper every day. So they used to have a huge, database about all the sentences or all the articles written by many people. So they have collected and put as a database. So by corpus, we mean like a data of a particular language, which is in a standard form. Say in BBC, they used to collect all the word or all the, sentences given by the reporter or by the editor. So it's a huge corpus being created by BBC and Reuters. So like if suppose the corpus is in terms of lakhs or crores, the number of sentences are in terms of crores or in terms of lakhs or in terms of millions or billions. So what happens is you can start finding this probability looking on all those sentences. Like say, for example, there are some 3 lakhs of sentences are there. Of that, definitely someone might have already used this phrase, the man from Jupiter, or otherwise in that 3 lakh sentences, there will be circumstance of, using the very word the. So you'll be finding the probability of the. there will be high chances of having the probability of the main. May not be this in this particular sentence, maybe say like the main and the woman. So still in that sentence, the main is being used. So from that 3 lakh sentences, the system will try to collect the probability of the main. By that, the system can just conclude that there is nothing wrong in the sentence. Okay, then the system will try to find the main from also. The main from also, because it may not be from this particular sentence, maybe in another sentence also, the main from is being used in another sentence. So when you try to find the probability of this may also be very high. And then comes the main from Jupiter. So looking at, getting the product, all these things, you will be getting a value which is from 0 to 1. If it is near to 1, then you may conclude that this very particular sentence is almost right. If it tends to 0, then you may conclude that this sentence or this phrase doesn't exist, or there is something wrong in the grammar of this phrase. So that is how we computer engineers try to design algorithms based on the probability. So that is one example. Then we'll look on to another model, like n-gram model. So this is another simple thing. Will be like the previous case, like the conditional probability. Here, this is a simple another one. Let me not discuss with the formula, but I'll just cite you an example here. By unigram, we are going to find the probability of one single word. Then by bigram, we are going to find the probability of two words at a time. By trigram, we are going to find the probability of three words at a time, maybe quagram. So n-gram, any number of combination of words. So here, this is a combination of 1 word. This is a combination of 2 words. This is a combination of 3 words. This is a combination of 4 words. Maybe it can keep on carrying. Okay, till n-gram. Now let's see how this is happening again. Say, for example, the same phrase now. If I have to look at the unigram, I have to find the probability of the existence of the existence of man, the existence of, or otherwise the probability of from that. Remember, I'm finding that probability from that huge corpus, which may be around some 3 lakh, 4 lakh, whatever it be, whatever collection you are having. Of that collection, you have to find out whether the is there, or otherwise the main is there in that collection of words, or a collection of sentence, which is nothing but a corpus. So this is unigram. Then goes to the bigram again. Bigram, as I told you, like we are going to consider two words at a time. I'll have to start this the with the start of the sentence. So that is an S here. So which means like we are supposed to check whether this the usually used to start the phrase or start the sentence. So I'm trying to find whether the beginning exists with the word the, probability of it. Then I'm trying to find the main from main, the main from Jupiter. That is what is being done here. You're going to find the probability of that from that huge corpus. Definitely, if suppose this is very frequently used, the probability will be very high and will tends to 1. Then you can again conclude that there is nothing wrong with this, the main from Jupiter. Then trigram again, you have to consider 3 words at a time. So this is one example. Now, look at the hello. No, okay, fine. Now let's look at the matrix here. We'll try to form a matrix here, and then we'll just conclude with what we have discussed earlier. Let's take about the bigram in the matrix form. We all know, if suppose it is a very see here. In this example, we are considering 9,222 sentences of English. Of that, what happened is we are trying to find, I want to eat Chinese food lunch spent. This is the word. I'm trying to find whether this sentence is right or wrong, or is there, if it is wrong, where maybe the mistake. That is what we are trying to find it out. So I'm just designing a matrix here. And then in the matrix, what happened is we are trying to find the frequency of it. How? Say, for example, say, for example, in the sentence, the probability of having I followed by I is very less. It's coming only up to 5. But the probability of I1 is too high, which means like I1 won't have any problem in the formation of a sentence, or otherwise the syntax of the sentence. So I1 will have a very high frequency. I2, that doesn't make sense, and none of the writer will be writing anything very silly. I2 will never be used. So in the corpus or in the sentence, you will never find something, a word, consecutive word, which is I2. So it will be 0. I-it will be, of course, there will be some frequency there, because I-it generally used to say. Maybe in this sentences, maybe someone might have not used it frequently, but still it exists. Again, I Chinese is a very wrong English. So the sentence, the frequency will be almost 0. Like that. So one I won't be there, 1 won't be there, 1 2 will be there. 1 2 is like a high frequency here again. 2 it is also another high frequency here. It Chinese is also a high frequency sort of thing here. A Chinese food is also a very high frequency here. Again, here also, it lunch is also a very high frequency sort of thing. To Spain is also a very high frequency sort of thing. So looking at the frequency sort of thing, we can just come up with the syntax correction. Here we are not using any rule. We are depending on the corpus which is already there. We are trying to just find out the probability of what is there in the sentence, which is already exists. Which means like we are trying to find, we are just making it some supervised learning sort of thing. So this is one thing. Then, so once you get the frequency here, you can just find the probability, and then you can conclude it that I want to eat Chinese food, lunch, Spain, like whatever it be, you can just come up to a certain conclusion, like whether this is right or wrong. I am drawing this example at the level of sentence. You can just use this algorithm to find or to just make a spelling checker. A spell checker can also be designed through this probability. If you have a huge corpus, you can just say like W followed by A. If you check it and say like the frequency is very high, then there may not be any mistake in the spelling. AN, how is this, frequency in that? NT, how is the frequency in that? So that is another thing. Yes, of course, there are different algorithms for finding the spelling also. But here, what I'm discussing here is the application of bigram, and hope this can be another good concept of using the probability or the statistical method, living away or moving away from the rule base. The drawbacks are there. Of course, the drawbacks are there. Drawbacks in sense like, if you keep on increasing the comparison keeps on increasing. What is required in the computer is the efficiency of the computer. The efficiency in sense like, if you keep searching, the computer will become slow, or otherwise it will take a lot of time. The time efficiency will be very low. So whatever it is, if you keep on increasing, saying like you are following some n-gram, the comparison will keep on increasing. Say, for example, I'm getting some 10,000 word unigram, you're going to compare only 10,000 times. Bigram, you're going to compare 10,000 into 10,000. See this much number of comparison you are going to make. And then trigram you are giving, then you are going to make this much comparison. So if you keep on increasing, the time consumption will be more, and then you may not be able to give the answer on time. So there are plus point and minus point for increasing or decreasing the number of n. If you keep on increasing, the accuracy will be high, but the computer system will become slow. If you decrease the number of n, the efficiency will be high. Efficiency will be high, but the accuracy will be low because there is no comparison. You are reducing the comparison of the following word or the consecutive words. So that is the idea here. Now, net Bayes rule. This is another probabilistic method. Like we start with the conditional probability, apply the chain rule, and then we got the Bayes rule. Now we are deriving something here. Maybe I should wind it up because I should not take much time here because I'm taking a lot of time explaining all those things. Okay, fine. There is another algorithm here we follow. Now what happened here again is, we'll check it out one example here. Let's forget about these rules. I'll just explain you how this really works in NLP. Say, for example, this happens for the author identification also. Author identification. A simple example. This, say, by author identification, we can say like the system will try to find out who the author is. If suppose someone has written an article, or otherwise say, let's say like there are 3 editors working in a newspaper. Okay, so each editor keeps on writing different articles. Now what happened is, there are few, the system come across few article which doesn't mention any, which doesn't mention about any details about the author. So we may be asking one question, or the system may be asking one question, the computer may be asking one question, like who has written this article? Maybe it may be like a confusing sort of thing, but it will be easy, I should say. It will be easy. Why? Logically, if you look at the way, if suppose someone has written an article and if it's been given to you, and then start asking you like, who has written this article? You can just come up and read the article, and maybe you can just answer like, this article is written by Mr. X, Y, or Z. How? The first thing is looking at the vocabulary of the, vocabulary used in that very particular article. That is one thing. And then the complexity of the sentence may be another point, or maybe something. There may be different characteristics. Based on that characteristics, we may be able to identify like this article this article is written by this particular author, X, Y, or Z. In that manner, the system can also be very intelligent, finding out who the author is. So this is one example here again. So for example, like there are certain, there are 4 documents here. Consider like 1, 2, 3, 4 are the documents. In the document, the vocabulary used is Chinese, Beijing Chinese. That first document is using like this. The second document is using 3 words, Chinese, Shanghai. Third document used Chinese and Macau. The fourth document used Tokyo, Japan, Chinese. Now, the first document, what I'm going to find out is, we are going to find out if suppose any document is there which is unlisted, the document is supposed to be identify whether it's a Chinese document or it's not a Chinese document. That's my target here with this example. So what happened is, we have certain documents which is already there in our database, or otherwise we are having a corpus which is already there in order to identify, which is already identified. The first document is a Chinese one. The second document is also a Chinese one. The third document is also a Chinese one. The fourth document is not a Chinese one, because looking at the vocabulary here. Now my job is, I'm having a 5th document which is unidentified. I'm going to check it out whether it's a Chinese document or it's not a Chinese document. So that is what, we are going to apply this probabilistic theorem. So what happened is, if the system can identify correctly that this particular document number 5 is a Chinese one, then we will definitely say like the system is very intelligent, which is nothing but an artificial intelligence or AI. So let's start finding it out how this is being calculated. I say with the formula over here, I have identified all these things. We got a value here. Again with a classifier formula, we identify the probability of all those things, and we come up with the probability here now. C is a Chinese document. C bar signifies not Chinese. So the probability, if we find for the document number 5, the probability for Chinese document is higher than the document which is not Chinese. Thus, it can conclude that this document number 5 is a Chinese document. So this becomes, this can conclude that the document number 5 is a Chinese document. Once, if suppose the system gives you the answer that the document number 5 is a Chinese document, you will definitely say like, yes, this system is very intelligent. This is how this system AI works and how this language is implemented in the through some algorithm, or otherwise we breach a gap between the language and the computing world. So this is another example. Then comes a little bit of higher version, which is called CRF. This is another supervised method. Supervised in sense like the output is known. We'll try to list out all the take data, we'll give it in the system, or we'll design the formula for, we'll design the algorithm applying conditional random fill, and it will automatically give you the answer. If an untagged or if an unidentified file is being given. This required, especially it depends on the feature or the characteristics. This very particular function is very important. With this very particular function, it will identify whether this particular, whether the objective is, we'll try to classify that particular objectives in that very particular class. That is what is happened in the conditional random field, or otherwise called as CRF. See, for example, this is how we have applied for the Manipuri POS tagger in using CRF. Maybe it may not be 100% right, but this is how our system gives the output. We try implementing CRF, and these are the characteristics which we have given. With these characteristics, we identify the part of speech tagging for the Manipuri. So these are the tag which is being given here. May not be, I tell you very frankly again, it may not be 100% correct, because we are still on the, we are still working on it. So this is the thing. This is how it is working. How we are bridging the gap between the computer algorithm and the language. Once we identify all this part of speech, we can just move on to some other level. That is our target. So each and every language need to identify all this part of speech first. Then we have another algorithm or another concept of support vector machine. This is another algorithm. This is another method of identification or classification, or otherwise classifier. Here, look at here, like maybe like this is another one class and this is one class. When I say class, you may be confused, but to be very frank with you, or to your understanding, I can just say like, you can just consider this class as noun and this class may be verb. Okay, so I'm trying to find, I'm trying to draw a line in between these two class, which means like these are the words, which is noun. These are the words, or otherwise these are the characteristics in order to identify the noun. These are the characteristics in order to identify the verbs, or otherwise these are the verb words. I'm going to classify with this line. I'm trying to classify with this line, like this groups comes under noun group, this groups or this group of words comes under the verb. So this is only for the two class. thing about in the case where you have multiple classes, you have verbs, you have pronouns, you have all those things. We are going to draw a line on the system. So this is another example. Like the complexity here is not only the classification of the two classes. I'm just taking example of two classes. Okay, maybe this is noun and this is verb. Thing is like you can draw the line in such a manner like it will definitely classify the two things, but you may have a possibility. It may be there will be a possibility.
Yeah, I
Yeah.
just wanted to remind you, sir, that we have almost 5 minutes to wind up. So,
Okay, fine.
yeah.
I'll just try to wind it up. No problem. Maybe can
Okay.
you just give me 5 minutes or something?
Yeah, sure. 5 minutes. That is what
Okay,
I
fine.
said.
No
Yeah.
problem. So this is another one where we'll try to classify the things. So like we're trying to find it out all these things, and then we're trying to find the best line to classify the things. So that is one thing. So like even for the NER using SPM, we have done it. And then for the Manipuri, we identify all these things like the names are being identified here, and the base features, we got it here. Then this is how we identify the name entity for the using the SVM. Then you have little bit of advanced method like artificial neural network and maybe deep learning. Say for example, for ANN, the concept from neuron is being taken, and then we try to find out the formulas on it. So the classical NLP works here. You have a language here, you have pre-processing sort of thing, you'll try to model it, and then you'll find the output. What in the deep learning is happening is like the inputs will be given, or otherwise the characteristics will be given here. Here the process will take place. One after the output will be given to another one output, and then output will give. So analysis will take place by the system itself, and then the output will be given automatically. So these are done almost like the rule base or something like that. But here, the safe learning is being done here, and then the output is being given here. Okay, for the using the deep learning. So like here, again, with the machine learning, we have applied to deep learning. The first part, we apply the concept of machine learning here for the feature extraction. And then these are the hidden layers, and the output is being taken out. So this is how it's happened. Now, even with the deep learning, we have applied in Manipuri also for NER, again, deep learning, like Chief Minister Matungda or something like that. And we try to identify, these are the input, this one. Okay, so what happened is, we find an accuracy of some 97% for this using deep learning. Okay, so this is where another application is being done for the language with the algorithm. So to summarize about all these things, we have talked about the artificial intelligence, or in that we talk about the machine learning. Then you find the deep learning again, which is the current hot topic. So let me conclude it here. Like if we have to talk about the computing, it is independent. It is not dependent to any of the language. It is independent. Computing can be done for the Manipuri, computing can be done for the Nagamese, maybe the Assamese, maybe Hindi, whatever it be. Another thing is, we need to find some advancement in order to bridge the gap between the language and the computing. So that is one thing. Then new advanced algorithm will be coming and should come, because we need to keep doing research work on all these things. We may have different algorithm for different language, but for the same objective. Like for example, POS tagging. POS tagging, which means like the algorithm which is designed for Manipuri may not be acceptable for another language. So the objective is finding the POS tagging, but the algorithm will be different. Then generally for the Tibeto-Burman, as we have been talking in the beginning, like Tibeto-Burman, we need to do a lot of work for this. And then machine learning is another direction apart from what rule basis. Then things like we human are cozy or we very much lazy. Maybe the machine will replace us one day, and then it will be a very difficult time for us. So we need to be very careful. It's not like we do research, and then at the end of the day, it will be a very productive one. Maybe it may be another vice versa sort of thing. So that maybe the machine may start talking among themselves and they may design another language which we cannot understand. That is also another possible area. We may be thinking like with all this machine translation sort of thing, we may be thinking like what to say, we have instructed the system and then the system is only learning. It may be in the background, the system may start learning itself and they may start talking on their own language, which we human cannot understand. So that may be another drastic sort of thing. Maybe you may be thinking like this is some sort of science fiction, but this may become another reality. So at that time, it may be very, very difficult for us. So these are the references which I gave, and fine. This is where it ends up. And thank you very much.
Thank you. Thank you very much for your very broad and extensive and very enlightening talk on the basic idea that you could give. It's so broad and extensive on computational language and machine learning and artificial intelligence. I mean, we all are familiar with at least some of these terms and uses, but the way you have shown us, in fact, the way you have demonstrated the algorithms, it makes things a bit simpler for us to understand and see how much scope we can also put for Tibeto-Burman languages of Northeast India. It's a very new area for data computation, and I would like to thank you very much for your talk on this. So I hope there will be some questions or suggestions. We can still take some 5 to 10 minutes if required, if anybody has any comments or suggestions or questions.
Sure.
Before anybody has any questions, I just wanted to know, we basically in our languages, we face problems when we tag and parse in terms of ambiguity. So what kind of algorithms do you use to disambiguate the senses? That might be a problem in machine translation, and sometimes even I do not have a proper answer for my students. So how do we resolve this
That's a
kind
very
of
good
a
question,
problem?
actually. Yeah, that's a very good question, Monali, because like that's another big headache for the algorithm designer also. Like we cannot every time go with the rule, as I keep on telling about that. Now the thing is like we have to rely on machine learning. That is the only solution as of now, because like ambiguity, if we have to look, then it depends. We can just look at the context sometimes, context of the sentence sometimes, or otherwise the context for looking at the whole document. So looking at the whole document, say for example, as I told you, like Washington is in America. So suppose like if I say like Washington is in America, if the whole document narrates about the place of something or something like that, then we can conclude like with the observation from the whole document, we can just say like that particular Washington is the name of a place. But whereas if someone is, in the middle of the conversation or something like that in the document, then we may just come to almost to a conclusion that this Washington can be maybe name of a person. So looking at the context, we can just differentiate the ambiguity. That is the solution which we are trying to find it out as of now. But maybe in some cases, through linguistic rules, we can also even distinguish the ambiguity. That's how the role of machine learning is applicable.
And since you have mentioned, and it's very obvious that TB languages being agglutinative, there will be a lot of problems in segmenting and identifying the roots and morphemes, because sometimes they are also fused morphemes because of morphological conditioning. So, for example, if there is if there are two prefixes, I mean two one prefix and there's another one, suppose e and u together becoming if there is an e-uma and becomes so in that case, how will it be possible to segment it? I mean, in terms of
what I have done is we have already done one experiment for identification of morpheme. In our case, what happened is, again, comes with the probability again. So what we have done is we try to identify the syllable first. Syllable and morphemes are different, right? As you know, as you have the background of linguistics, you know the difference between syllable and morpheme. Like, it's not compulsory that all syllables will become a morpheme. So like, it may be a combination of syllable that forms a morpheme also. So what we have done is we try to find out the frequency of the combination of the consonant on vowels or some sort of that. We try to find out the formation of the word in a particular language through getting lot of corpus. Like, I mean, so at the end we find something like our Manipuri language comes up with consonant alone, also a combination of C and B, something like that. We find all the, I mean, combination schema. So at the end, especially for Manipuri, we find some, I think around some 8 or 9 combinations of that. Okay, then of that, not more than that. So after finding the combination of those things, we try to use the standard deviation formula. Then we try to find out, like, whosoever come near to the deviated, or I mean maximum deviation sort of thing, then that can be a morpheme. That works very well, and almost like it comes to an accuracy of around some 95%. So that is another solution for that. So for getting to a particular word, and then we are trying to find the combination sort of thing. Once we get that combination, formula, then it is very simple for the rest of the words, which will become an input in order to identify the morpheme. That is how we have done in our case for the Manipuri.
That means for TB languages which are still lacking in documentation, it will become a huge daunting task for
Definitely.
NLP.
Definitely,
because there's still a lot of data to collect.
Yeah, I would suggest, like, if we have to really work for the TB language, what we can do is, yes, of course, for Manipuri, we have, up to some extent, we have started collecting, we are having some, good number of corpus. We have collected from the news agencies and all. So in that manner, if suppose all this TB language can start collecting the corpus in a huge number, then the future work will be very easy. Because unless we have that huge corpus, it will be a very, I mean, questionable sort of thing whether we will be able to work it on this particular language or not. So the first thing is the collection of the corpus. So I would suggest those languages which are very new in NLP to start collecting the corpus. Once you get it, then things can be done easily.
Thank you very much, Dr. Kishorjit, for answering to my queries. Bijan, I think, has some question.
Oh yeah, thank you, Monali. Thank you, Tamo, for that detailed and comprehensive presentation. Let's say, for the minority language or the lesser known, I was just wondering, what is your best suggestion that we can build up a good corpus for such languages?
Corpus, like, we call it as low resource languages. So for that, say for example, in my case also for the Manipuri, what happened is, like, I start working with some 25 to 50,000 sentences, which I manually have to get it from a linguist. I have to pay for the, for the tagging of each and every word. In that manner, if you can start getting some linguist or some expert in that for that language, and start collecting the corpus, that is the only option. Or otherwise, if you have news publication, then you can collect every day, all the corpuses every day. So there is another solution. At the beginning, in our case, what happened is collecting corpus was a very hard task for us, because even the phones were not in a standard one, because we use, as you know, like we use Bengali script and Meitei script. So Bengali script, we started collecting the Bengali script, which was abundant in the newspaper. But later on, when I tried, or when our team started shifting from Bengali script to Meitei script, there was another issue. But again, luckily, we get a newspaper which is being published in Meitei, that Huel. From there, we started collecting the corpus again. And then even we designed a software for a transliteration. By transliteration, you might have already know about this also. Transliteration will be something where the script will be changed, getting the same word. Keeping the same word. Say, for example, Manipuri, like the Bengali script will be transformed to the Meitei script. We design a software for that also, and then those corpus which was collected in Bengali is being transformed to the Meitei script. That is how we have done it for the collection of corpus. So my suggestion will be, if you really want to start working on that particular language, you start it manually. If you have other resources like newspaper or something, collect it from there. But be careful, like if you are having a script in particular, then go to the standard script. Because in Manipuri also, what happened is, like for the Meitei, the script which was earlier used, like Ratha, then Kanglaya Chapa, these are all the fonts which was being used by the printing agencies. Those are not Unicode fonts. So there's another problem, another issue when we try to program. Okay, so when you try to collect the corpus, if it is Roman, then it's okay. Or otherwise, if you are having your own script, just go with the Unicode font. So that will be my advice. So manually is the best one when it is a low resource language.
Okay, thank you, now.
Thank you, Dr. Bijen, for your question. Are there any more questions from the participants? Okay. So if there are no more questions, then I'd like to request Dr. Bijen to kindly give vote of thanks.
Okay, thank you, Monali. Sorry for my video, as I'm facing fluctuation in my connectivity. Just to enhance the connectivity, I'm turning off it. Okay, thank you, Dr. Nongmeikapam Kishorjit Singh, for your detailed and comprehensive presentation on in the area of NLP. So we came to know so many things today from your talk. Thank you very much for that. And personally, I got enlightened also, where I have there are so many gray areas here. So I came to know many things about it. Thank you very much for that. And I would like to thank all our participants who were patiently listening to our presenter during his talk. And on top of this, I would like to thank all those participants who log out maybe because of the connectivity issue before we wind up our today's program. So I extend my heartfelt thanks to all those participants also. And apart from this, as we have already announced that this is the last and final weekly talk of the Tivlani that we were continuing from November 2020. So it is a great pleasure for me to propose a vote of thanks on, especially on today's talk that is presented by Dr. Kishorjit Singh, who was, the presentation was well, organized in such a way that even the MA students can understand what is NLP and its and its related fields. Thank you very much for that talk. So I think that's all that I can share. If Monali, you have something, then we can share also. Yes, apart from this, as we are announcing that this is the last talk, we are planning to come up with some more activities, Tivlanais activities, that will be announced very soon. So please stay tuned with this Tivlanai. Yes, it is because of all your kind support and your cooperation that we are able to implement, or we are able to work out in such a effective way. Thank you very much. Yes, over to you, Manali. If you have anything to share, then that's all from my end.
Thank you very much, Dr. Bijen, for also enhancing it on Tiblani activities that we have begun. Initially, it started with just, I think, 5 to 10 of us, and then now the WhatsApp group of Tiblani is crossing 130 participants, and we are expanding, and we're expanding even areas of areas and topics of research in our talk series, which we will, of course, we will keep a record. And this talk today is one of the most special talk series, because it ended up with computational linguistics, and we need help of we as documentary linguists, since most of us are all into documentation and description. We as the documentary and descriptive linguists, we do need help of computer scientists to take our documentation archived, and to keep a data repository. I think this could be a kind of beginning towards our future endeavors as Tiblanai Society. So thank you to our speaker, Dr. Kishorjit, once again, and thank you to all the participants present here today for your.
Yes, before that, I, on behalf of Tivlanai, would like to wish Tamo Kishorjit's ongoing process of the driverless vehicle a grand success, and all your works comes with a very effective success. We wish that we are eagerly waiting for that also. Thank you.
Just come to, we'll come to the news very soon.
Thank you very much to all. Good evening and good night.
It was my pleasure.
Okay. Good evening to all.
Yeah, bye-bye.
Bye-bye.
Bye.